In the spring of 2026, a pseudonymous security researcher known as Nightmare Eclipse engaged in a systematic retaliatory campaign against Microsoft. Claiming the company deleted their bug bounty account and withheld payments, the researcher bypassed traditional disclosure channels completely. They dumped working proof-of-concept exploits for 6 critical, unpatched Windows vulnerabilities directly onto public GitHub repositories. This diagram shows the specific targets of those 6 exploits. Notice how they bypass the outer perimeter and go straight for core kernel components. Exploits labeled Bluehammer and Red Sun directly attack Microsoft Defender, elevating unprivileged users to system-level control, while another vulnerability, Yellow Key, completely bypasses BitLocker drive encryption. The fallout hit enterprise networks almost instantly. Advanced threat actors and opportunistic ransomware syndicates integrated these proofs of concept into automated exploit chains. By combining local privilege escalation with defense evasion tools, attackers could temporarily blind endpoint protection software, leaving the door wide open to drop domain-wide encryption payloads. By burning the bridge with independent researchers, a major software vendor inadvertently handed active, unpatched weapons to cybercriminals. Standard defense systems like antivirus and encryption stopped protecting the network and instead became the exact attack surfaces adversaries used to tear it down. But this human-driven crisis was only a symptom of a much larger systemic threat. In early 2026, Anthropic conducted internal evaluations of its Claude Mythos preview model. This testing revealed a massive jump in the ability of frontier AI systems to autonomously locate software flaws. This chart illustrates the capability gap. While previous generation AI systems could locate around 20 exploitable vulnerabilities in a highly complex code base like the Firefox browser, the Mythos model autonomously identified nearly 300. Scaled across all major operating systems, the model located tens of thousands of high-severity zero-day exploits in a single month. Active intelligence reports quickly validated this danger. Chinese state-sponsored actors had already begun deploying custom AI agents to autonomously execute 80 to 90% of their network intrusion workflows. These automated systems operate at speeds that easily bypass human defensive capabilities. The barrier to discovering and weaponizing software vulnerabilities has dropped to zero. With AI agents capable of generating and executing multi-step exploit chains in real time, the traditional defense in-depth model of simply patching bugs and building higher network walls no longer works. Confronted with this dual-use capability, the White House attempted to intervene. On June 2, 2026, the President signed an executive order titled Promoting Advanced Artificial Intelligence Innovation and Security. The initial draft of this order proposed a mandatory 90-day pre-release review window, requiring developers of advanced AI models to submit their system weights to federal intelligence agencies for cyber capability evaluation. This met immediate resistance from tech founders and political allies, who argued a strict bottleneck would stall American development. Influential Silicon Valley executives lobbied the administration directly, warning that stringent regulations would hand the global technology lead to competitors. Influenced by this pressure, the administration drastically watered down the order, reducing the review window to 30 days and making the entire pre-release evaluation program strictly voluntary. Because participation is entirely optional, developers can bypass government safety testing completely. This voluntary framework entirely ignores the unchecked proliferation of foreign open-weights models like DeepSeek V4 Pro, which independent analysts found to lag behind American commercial models by a mere 8 months. At the same time, corporations are using the legal system to hide their own engineering flaws. When open-source hardware pioneer Adafruit discovered a critical security misconfiguration that exposed user data on the AI platform Flux.ai, they attempted a responsible disclosure. In response, Flux.ai hired elite legal counsel and threatened Adafruit with criminal prosecution under the Computer Fraud and Abuse Act to suppress the report. Threatening independent researchers with prison time while relying on a few cooperative developers to voluntarily submit to safety tests does not physically stop an automated hacking tool. Recognizing that policy and litigation were failing, the software industry turned to infrastructure. At the Build 2026 Developer Conference in San Francisco, Microsoft introduced a core architectural shift called Microsoft Execution Containers, or MXC. The operating system must now assume that any autonomous AI agent is a hostile entity. Because these agents are designed to accept natural language goals, reason, and write code dynamically, they cannot be made inherently safe. Instead, their execution environment must be physically isolated at runtime. This diagram shows the architecture of MXC's composable sandbox spectrum. Session isolation separates the agent's environment from the user's desktop, locking away the clipboard, interface, and network ports. If a compromised agent attempts to inject an unauthorized keystroke, the MXC boundary immediately blocks and logs the event. By requiring developers to declare exactly what files and resources an agent can access before it ever runs, the operating system discards the concept of software trust entirely, replacing it with strict zero-trust physical isolation. Running these continuous, real-time reasoning workflows in kernel-level sandboxes creates a massive physical bottleneck in the data center. Training an AI model usually requires 1 CPU for every 8 GPUs. But orchestrating an autonomous agent demands a CPU to GPU ratio of 1:1 or higher. This compute transition dominated the Computex 2026 hardware conference in Taipei, where Intel launched its Clearwater Forest Xeon 6 Plus data center processors. This schematic compares a traditional GPU-heavy server architecture with the new 1:1 CPU to GPU layout of the Xeon 6 Plus infrastructure. Packing 288 efficient cores into a single processor handles the high-density demands of agentic AI. To manage privacy, companies deploy hybrid models. Sensitive queries process locally on internal hardware, while reasoning-heavy tasks route to massive cloud clusters. This silicon-level re-engineering delivers the raw physical power and edge compute capability required to host high-density agent workflows and enforce complex OS-level sandboxing right on local hardware. Standard system prompts and static guardrails offer zero protection against an AI capable of dynamically generating its own zero-day exploit chains. Enterprise IT leaders must mandate strict operating system-level containerization for all AI agents. Using environments like Microsoft execution containers, administrators must enforce rigid access policies and assign unique local IDs to track, audit, and trace every single machine action. Organizations need to invest in local, high-density edge compute hardware. Processing sensitive inference tasks on premises keeps proprietary data completely out of the cloud and minimizes exposure to external model providers. At the policy layer, corporate entities must replace aggressive litigation with transparent vulnerability disclosure policies. Lawmakers must discard fragile, voluntary frameworks and establish mandatory, capability-based safety testing conducted by independent supercomputing centers. The autonomous AI threat is permanent. Relying on polite agreements and easily bypassed software filters is a guaranteed path to compromise. Enterprise survival now requires a comprehensive, integrated container, built from legal accountability, operating system sandboxing, and purpose-built silicon.